I want the forest, point A, I want point A to be a part of my solution. So I want the shaded regions to overlap right here where point A is. Can you come up with the two inequalities on your own? All right, so here's what I want right now. And don't do this on your paper. Don't make a mess. Shade. Shade. So they intersect up here where point A is. Can you come up with those two inequalities? Well, I did the hard work for you. What did I provide you? The equation. So let's start with, was that 3 or 5? 5t minus 7p. I'm not going to put an equals there because there's going to be an inequality there in a second. 70. You guys got to help me find that inequality now. Should it be less than? Should it be greater than? Should it throw an or equal to onto that bad boy? Well, you tell me. If A is going to be part of the solution, should I shade above or below this line? Above, right? I just showed you. Shade above, which means what's not going to be part of the solution? 0, 0. So what sign do I need to put here where 0, 0 will not be a solution? All right? Think about that right now. All right? If you need to talk it over with people around you, feel free. All right? But I do not want 0, 0 to be part of the solution because I'm shading away from it. So what sign would I need to put there where 0, 0 is not a solution? And if you still have no idea, throw a sign up there and see if it is or not. Throw a sign. Cooper, what do you got? Greater than 70. Well, let's see. Ready? Everyone plug in 0, 0 for T and P. What do you get on the left side? Is 0 greater than 70? Nope, so I would shade away. Nice job. One last thing, though, with it. Anybody want to adjust what he told me? And Meg? Y or equal to, because this is a, appears to be a solid line. Okay, appears to be a solid line. Okay, there's one. Let's go to the other one. Down here for deserts, I have 3t minus 35p and something with negative 140. Where would you guys like to shade for this, for A to be in the solution? Where am I going to shade, above or below? So A is part of it. Above still, so do I want 0, 0 to be a solution? Nope, so go ahead. You figure out the sign now. What should the sign be where 0, 0 is still not a solution? You do not want 0, 0 to be a solution. Ideas? Greater than or less than? Which one? Okay, well, let me see. I'll throw a less than in there. That's what I heard first. So ready? Plug in 0, 0. You get 0 to the left. Is 0, oh boy, this is always a hoot. Is 0 less than negative 40? Negative 140? No. So it wouldn't be part of the solution, and I just have to add the or equal to. Questions on where I came up with the signs before you do one like this tomorrow in your group? I'll provide the equation. I have no, that's not a big deal. Anything? All right, time to come up with your own now. Hey, there's a quick fact for you. Many elevators can only hold 2,000 pounds. Go figure. Okay. All right, go figure. Average child, 50-pounder. Average adult, I guess we're going with, is 150 here. Write an inequality. X is going to be the number of children. Y will be the number of adults. And here's the key. I got fooled by this over the break here when I was doing the answer key. Will cause the elevator to be overloaded. So we want to overload the elevator when we write this inequality. All right, overload the elevator. All right, X is the number of children. How much is each child going to weigh here? About 50 pounds. So 50 times how many children we have, X. You guys want to try to finish it now. Plus, what about my adults? 150Y. And again, keep in mind, we are overloading the elevator. What's going to overload it? What symbol here? Greater than, and there was a little controversy third period. Should I put the or equal to? No, because capacity. It can hold 2,000, but nothing more. All right. before we graph, we're going to keep it to quadrant 1. Anybody know why? What's X and Y represent here? Number of children and adults. Can I have negative? No. So we're gonna keep everything to quadrant 1. So that's why I've set it up like this. There's no need to set it up down the middle like usual. There's no need. All right. Keep them all positive. All right. Bless you. All right. Let's graph this. These are some large numbers, huh, guys? The graph. I'm going to make a little suggestion for you. Instead of solving for y, I'm going to make a suggestion that I'd love for you to take and use. Do you know how many points it takes to make a full line? Minimum number of points it takes to make a line? 2. I'm going to help you find those 2 points. One of them is going to be on the y-axis, and the other one's going to be on the x-axis. All right. The one on the y-axis you guys refer to as the y-intercept, right? Okay. Without solving for y. I don't want to solve for y here. Without solving for y, is there a quick way I can do something up here and find out where this is going to cross the y-axis? Here's how. Every single coordinate on here, the x-coordinate, here you go, ready? X-coordinate's what there? The x-coordinate is? What's the x-coordinate there? What's the x-coordinate there? 0. So what am I telling you? Everywhere you see an x, plug in a 0. So 50 times 0 plus 150y equals 2,000. I'm putting equals because I want to know what the y is. So you guys go ahead and solve. So you get about what? 13.3 repeating for the y? So what point, what's 1 point on the line at least? Oh, no. 0, 13.3. And then how do you think you find your x-intercept? Plug in 0 for y now. Go ahead. So now to find your x-intercept. And again, I just think this might be easier for you guys instead of just solving for y every time. So 50x, excuse me, plus 150 times 0 equals 2,000. Where's across the x-axis? 40, 0. Yep. Before I graph those points, though, yeah, we got to set that up because I don't think we're going by ones certain places. Well, here I got to at least have 13.3 on there. So could I go by ones? Do I have enough spaces here to go by ones to fit 13.3 on there? I think it goes up to 15. Okay, so we can go by ones on the y-axis. That's fine. You don't have to show all of them either. You can just show a couple that says, hey, I'm going by ones here, champ. But those of us who are hardcore, we go all in here. That's not going to work for the x-axis, though, because I need 40, and I can't go by ones. I'm never going to reach it. Suggestions? It's 5s, fine. It doesn't bother me. Go by 5s, all right. So 5, 10, and I'm not definitely writing all these. 20. I guess I'm not going all in on this one. 50. We can keep going if you want. I am going by 5s. Okay, so about 13.3 was my y-intercept. 40 was my x-intercept. That makes a line. Before you guys go, whoa, what type of line? Dotted. Why? There's no or equal to, so it's got to be dashed, dotted, however you guys refer to it as. Please have a decent straight edge on you. Still missing a huge part, though. We worked on this Thursday, Friday before break. Huge part still to the inequality is, okay, you graphed it correctly, but still have to. We're not even ready for that yet. Not even ready for that yet. Don't even sniff that yet. There's only one line. I don't need to label. You're 0 for 2 already. How about I shade? There's a huge part. Yeah, shade, everybody. Above or below? We'll pick 0, 0. Let's find out. Everyone go ahead. Plug in your old 0, 0. Does it work? Oh, boy. I always get. Is 0 greater than 2,000? Nope. So shade away from it. Go ahead, everybody. Shade away. Now that's a good graph. All right, I'm going to turn it over to you guys now. Select an ordered pair that satisfies this inequality. Basically, give me an ordered pair in your solution set. Okay, give me an ordered pair, something decent that's already on the graph. That's part of the solution. Anybody want to volunteer here so I don't have to go to the numbers? Give me a number that is in the solution set.
It's not on the graph, though.
Squeeze. Squeeze. Anybody except for the goof troop back there want to provide me with a point? What do you want, Pat? What is it? 60 and 5. Yep, that looks good. 60 and 5. 65 is in there? Absolutely. All right, what's that mean? Pat gave me 60 and 5. What's that mean? What's the x coordinate again? What did we call x? So 60 children. $60 children and what's the 5? 5 adults would overload the elevator. Now, did we have to go so crazy as 60 children? No. Here you go. How about 5 children and 14 adults? Something a little bit more reasonable, all right, for an elevator. No one's getting in that one with 60 kids. All right. Questions? All right, one more here. Oh, this is a good one. A lot of reading here. Some of your favorite. A lot of reading. God, somebody knock him out. All right. Person's got some cash on them. They do not want to invest no more than $15,000. What's that mean? $15,000 or less. All right. They want to invest $15,000 or less. 2 options. He's got 2 options. He can go high risk, high yield. Ooh, high yield. Huh? They do that in economics or no? High risk, high reward, yes. All right. And the other is low risk, low yield. Okay. At least 2,000. What's that? All right, stop. At least 2,000. What's that? 2,000 or more, okay? To be placed in the high risk. And then the amount at low risk should be 3 times the amount at high risk. Graph those inequalities and tell me how much money I can put into each. All right, I know this is a lot. And you got a lot of stuff going through your head as far as writing the equation, graphing it, and shading it. Here's what I need from you right from the get-go. What are the two things I'm looking for? What are the two things we're looking for? The money I put into high risk and the money I put into low risk. Define those variables right now. Okay, what do we want high risk to be? So we'll let X equal high risk money. And Y be low risk money. That's the tough, I think that's the toughest part, is figuring out what do we need to figure, what do we need to solve for? The total amount of money he's going to invest can't be more than, okay, can we write an equation that says that? Total amount of money he's going to risk is not going to be any more than $15,000. What do you got for me here? Total amount of money, no more than $15,000. X plus Y, got to be, what's your inequality here? Less than or equal to your 15,000. Next one, at least 2,000 in the high risk. Which variable did we say high risk? X. You're going to put at least $2,000 into there. What's the sim? No Y here, just talking about high risk. At least 2,000, so it's got to be greater than or equal to 2,000. And this next one may be tricky, but I think you can get through it. I know you can. The amount invested at low risk, which was Y, at least. Oh no, just at least. Forget about the rest. At least. I know that 3 times. I'm getting that. I just want the inequality symbol for at least. Greater than or equal to. Okay, now 3 times your high risk. 3x. Here are the 3 equations we're going to graph now. Whew. Can you invest negative amount of money? No. What am I trying to show you? That we're still in quadrant 1. So go ahead. Make sure you get those down now while we're here. Still in quadrant 1. Our labels. We're talking about thousands of dollars here. Thousands. Now, if you don't, and I wouldn't blame you, I'm not going to, where you don't have to write 1,000, 2,000, 3,000, 4,000, 5,000. You can just put right at the bottom that those numbers you put are in thousands. So you can stick with single and double digits there. Okay, same thing on the y-axis. Hey, all these numbers here are in thousands. You do have to tell me that, though. Graph this one first. Before break, x equals a number. Horizontal or vertical? Which one was it? X equals a number. Horizontal or vertical? Vertical. Okay, so a vertical line going through 2,000, or in our case, 2. All right, a vertical line going through 2. Should label a couple of these just so we know we're going by ones. Don't shade, but label. All right, don't shade, but label your line. Yes, they're all going to be solid. Let's just go to x plus y less than or equal to 15,000. Find your x and y-intercept right now. I'll ask somebody in a second. Find your x and y-intercepts. Find your x and y-intercepts. Plug in 0 for x. This one should be a pretty quick one. There's not much to solve for. Ready? Here you go. 0 for X. What's your Y? 15,000. So 1 point's going to be 0, 15,000, and your other point will be 15,000, 0. Yep. Go ahead, graph those 2 points on your X and Y axes. So you got 15 and 15 on both axes there, which I believe should take you all the way across. And again, label that line right there. Okay, everyone all good so far before we get to this last one? Everyone got the 2 lines? Okay, next one. Now here's the problem sometimes with doing this X and Y intercept. Ready? Plug in 0 for X. What's your Y-intercept? It's going to be 0, 0, 0. Now, if I plugged in 0 for Y, divide both sides by 3, what's your X-intercept? Okay, that doesn't help me out when both of them are the same, when they're both 0. Any other way I can get through this? What's another way I could graph this? Oh, no. Come on, come on. What's the slope? What's the slope? 3 over 1. So where do you want me to go from here? Up 3 over? Yeah. So if your Y and X intercepts are both 0, you can still do rise over run. 1, 2, 3 over 1. 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 What is that? Last thing. I can't have it anymore where you guys just start shading like crazy and say, oh boy, there's a lot of colors. Where do they overlap? Here's where I need you to be starting right now. I need you to visualize where the shading's going to be to see where they overlap. Ready? This one right here, X plus Y less than 15,000. Everybody plug in 0, 0 right now and tell me if it's a part of the solution. If I plug in 0, 0, will it be part of the solution? Yes, meaning this line, I'm going to shade where? Above or below? Below. So visualize, okay, I'm coloring in this whole section below. Ready? Next one, your vertical line. 0, greater than 2,000. No. So would I want to shade to the right or to the left of that line? I don't want 0, 0 in there. To the right. So here's what I got so far. Down to the right. Do you see where they're going to intersect now? So right here, right now. This is where I'm intersecting before I get to the last line. All good. Last one. 0, 0. Ooh. It's on the line. Can't use it. Good deal. Can't use it if it's on the line. Pick another point for me that's not on the line that would be easy. That's what I was thinking. Wait, let's just stop the train right in its tracks. You want 4, 0? Okay, stud wants 4, 0 here. 4, 0 over here. Whew. Okay, ready? 4. What would I get here? 12. Is 0 greater than or equal to 12? No. So what I want to shade, ready? Hey, above it or below it if this wasn't a solution? Above. So everyone see where we're going here. Below, to the right, above. Do you see where they would intersect? Shade it in for me then. Shade it in where they would intersect. Again, below, to the right, above. Let's see, come on. It's not, I don't even know why I'm trying this. It's not going to work. Nope. Nope, I didn't think so. I didn't know. I didn't think so. There it is. Last question. And I know this is not on here, but I want to know. Give me a point, an actual point that is a clear point in that solution. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 311. Yep. What's that mean? He can put how much into his high risk? 3,000 and 11,000 into his low risk if he wants to satisfy all these requirements. Last question, and this is for you to check right now. How good is your straight edge? Can you tell the points that make up that shaded region? Can you clearly tell what those points are? Because on Thursday, I need to know what those points are. How good is your straight edge? Can you clearly tell what those points are that make up that shaded region? We're good? Okay, that's not for now, but I just want to make sure for Thursday you're using the good enough straight edge. Okay, tomorrow you're going to practice this with your group when you come in.